Hello, everybody. I'm Tahmina Ajmal. I'm from the University of Bedfordshire in Luton in United Kingdom, and I'm presenting the work that my PhD student, Tochukwu, the first author, has done basically. So rest of it is basically the whole group that we are working together. And this work is on the water quality index for the pollution detection in one of the lakes, that's Luton Lake in our university town, that's Luton. So the outline of the talk will be the introduction, the research objective, and a very brief test scenario. And then for those of you who are not familiar with this term, water quality index, I will give a very brief overview of what it is and how we measure that. And then I will discuss the selection of suitable techniques, and finally the results and the analysis and results, and after that the summary and what we are intending to do further on that. So for a very brief introduction, we have got the EU WFD desires the surface waters within the region to achieve a good ecology and quantitative and qualitative status, the description of physicochemical characteristics of water with regards to its uses and standards. This is what we call as the water quality. And there's a need to actually measure and know the water quality for all the surface water bodies. And this is needed by the major stakeholders and the decision support tools regarding the water quality. So most of the main problem that we have is that mostly the water monitoring is very resource limited, even in the developed countries as well. So we need to find the suitable techniques that give an indication of the water quality from the limited data. So we usually don't have the access to the large amount of data. We have to make do with the limited amount of data and get suitable kind of markers, indicators to the relevant stakeholders so that they can make a decision about the quality of the water. So the main research objective is to use the data available from online sensors and obtain a water quality index to inform the relevant stakeholders. And what we have done is that we have selected one of the lakes in our city, Luton. And the reason why we chose that was that in 2012, a major sewage leak incident occurred. And this was in the newspaper, and it was a kind of a major thing. And because of that, the thousands of fishes were killed. And interesting thing was that this went completely unnoticed unless and until the estate manager went around and he noticed thousands of fishes being dead there. So that was the thing that initiated and triggered our communication with the Luton estate, and they asked us to actually look into that. So this is the overview from the Google map, how the lake lies and the location of the two sensors that we have on the lake. So we have got two sensors installed on the lake, and they are installed by Environment Agency, which is the kind of the national agency in United Kingdom, which is responsible for managing all the surface waters. And in addition, there's also another one installed by the Luton airport, because there's some inputs, some kind of pollutants coming from the Luton airport also. So this is the two locations of the sensors, and this is our typical 6-head sensor that we are using. So there will be a sound, and on that we have got a 6-head sensors, and the kind of sensing that is being done is a typical dissolved oxygen, temperature, conductivity, turbidity, pH. These are typical parameters that are being measured there. And what we are trying to do is that trying to get all the data and give an indicative index to the stakeholders, to basically the Luton estate people, so that they can know when to take an action or when to inform or give a warning to an environment agency or things like that. So what we found was that this water quality index is the means by which the multiple diverse water quality data is summarized into a single value for consistent reporting to the public and interested parties. Unfortunately, there is not one single formula for water quality index, and it varies from from the research groups to research groups. So different people have used quite a varied calculation methods for this one. And it could be quite extensive. So these are examples of some of the existing water quality indices, which varies from country to country, and even in the same country, it varies from region to region. So in general, for the water quality index calculations, what we do is that we use the water quality index calculation. First of all, we have to do parameter selection to decide which parameters we are going to use, and then we use something called quality function, and then we calculate the sub-indices, and then use the aggregation with mathematical expression. So parameter selection, the most commonly used parameters are, which is of course for interest for any surface water, dissolved oxygen, fecal coliforms, pH, biochemical oxygen demand, temperature, total phosphate, nitrates, turbidity, total solids, etc., etc. But for us, what is of interest is a minimal water quality index, which has been used by some researchers, and it's used only through 3 parameters, which is turbidity, dissolved oxygen, and either conductivity or dissolved solids. So if you're doing a water quality index calculation, first of all, we have to assign weights and then compute the relative weights. And then after that, we have to calculate something which is called as a quality index, quality rating, which depends on the concentration of each parameter and the standard value for each parameter. So I will not dwell a lot into the mathematical details. This you can find in the paper. What I'm going to very quickly go into is our water quality minimum or water quality index calculation. So what this does is that, and this is because this is the method that we have used, is that it uses the parameters for the only 3 of the water quality indices. Which is dissolved oxygen, the conductivity, and turbidity. And we take a mean of all of them. And for this, what we need to do is that we need to use a normalization table. This has been researched by a lot of researchers and gives us the parametric values of all of these components. So depending upon which components we are using and what's the range of the values that it is lying, then we can find the normalization value for each of the parameters. So what we did was that we were doing this calculation, and in addition, we also did what's called as a box plot analysis. Box plot analysis, again, a statistical method that is used. And what this gives us is that because we are measuring the data every 15 minutes, so there's a huge pool of data that is lying there. And from that data, we did box plot analysis to give an indication about how and where the values are lying. So for each month, you will find, so we have done over the last year, approximately last year, from the September 14 till the April this year, and trying to see for both of these sensors. So EA stands for the Environment Agency sensor, and then we have got the airport sensor. So there are 2 sensors which are on the lake, and from both the sensors, we are trying to get an indication about if we could find a pattern for these values, for the variation of these values. And then our interest is to justify that water quality index minimum can give us a similar kind of indication. Because for doing box plot analysis, of course, that's not something that we could do online. It takes a while to actually analyze the data. So we did the box plot analysis for dissolved oxygen, and then for turbidity, and we did for conductivity. So here it is lying, the values are lying actually very much outside the expected range. So you can see the values between 50 and 200 microsecond are actually permissible levels. So here you'll find the values are actually lying much beyond that, which means the water was kind of dirty, not good. So this is the In terms of the water quality index, this is how we could specify or give the information to a layperson about the quality of water. So if the value water quality index is lying between 90 and 100, it's excellent, 70 and 90 is good, 50 and 70 is medium, 25 to 50 bad, and 0 to 25 is very bad, which means it's severe pollution. So what we did was that we calculated the water quality index now from all of our data for both of these sensors. So you can see the blue one is the Environment Agency sensor, the red is the from the airport sensors, and also marked on the graph are basically the ranges that we would like. Of course, the water is never excellent because there's a lot of pollution coming into there. And because it's surface water, this lake water, so we are not expecting it to be very, very clean. But we do find that sometimes the water is good for at least for the first sensor. For the second one, it is lying between medium, bad, and very bad. And so basically, when it goes below bad, then that is that point that we want some sort of markers or warnings going to the going to the relevant stakeholders. Okay, so I would very quickly summarize this. So what we have done was that we have adopted the water quality index minimum, and we found that this is actually a cost-effective method which could be explored in a lot of countries having the water quality monitoring and decision making. And the reason why we are saying that water quality index minimum is a sensible way of doing it is because we find that the values that we are getting from the water quality index minimum calculation actually comply with the data that we are getting from our box plot analysis, which is much more detailed for us. So you will find that it is the same kind of pattern that we are obtaining for the water quality index minimum. And again, and this also does show the seasonal patterns in the water quality data trends they are visualized. And it is easier and less time consuming to derive the water quality index with the methods used, while still giving a robust indication of the water quality. These are some of the references that we have used in this work. Thank you very much.